Good morning. So we're going to talk about something today called prime factorization. Prime factorization. So we've been talking about factors of numbers, and we are now going to talk about if we break a number down into all of the prime numbers, what would the prime factors of that number be? So we're going to make what are called factor trees. And the first factor tree that we're going to make is for the number 60. You're going to start with any two factors of 60. So this is when your divisibility rules come in really handy. You know that 60 has 2 as a factor because it's even. You know that 6 plus 0 is 6, and 6 is a multiple of 3. We know that 4 times 15 is 60. We know that 60 ends with ends with a 0. So it's divisible by 5 and 10. 60 was divisible by 2 and 3, so it's also divisible by 6. So you have a lot of choices. You could start with 2 times 30, and I'm going to make a second factor tree over here. You could also start with 6 times 10. So I'm going to focus on my first tree over here. So now we're going to think about the 100s chart that we did a few days ago. On the 100s chart, we highlighted 2 as being a prime factor. So if it's prime, we're going to circle that number. If it's not prime, like the number 30, we're going to make 2 more branches off the tree. This is when you can think again about your divisibility rules. 2 is a factor of 30 because it's even. 3 is a factor because 3 plus 0 is 3. 5 is a factor because it ends with a 0. 10 is a factor because it ends with a 0. And 6 is a factor because it was divisible by 2 and 3. So I'm going to do 5 times 6 is 30. I know for my 100s chart that the number 5 is prime, so I'm going to stop and circle that one. But 6 was composite, and I know 6 we get from 2 times 3. Okay, so I'm going to go through and highlight all of my prime factors. Now, the way that you're going to write your final answer is you're going to start with the lowest prime number, which is 2, and I see 2 2's. So we're going to write that as 2 squared, and then I have 1 3, and I have 1 5. And then we put a box around our prime factorization. Now, if you think about your answer, 2 squared is 4, 4 times 3 is 12, and 12 times 5 is 60. Check, that works. Let's look at the second factor tree for 60. So we could start with 6 times 10. 6 would branch off to 2 times 3. 2 is a prime number, and 3 is a prime number. So we're going to stop and circle those. Those do not get branched off again. And then 10 over here would be 2 times 5. So I'm going to highlight all of my prime factors so they kind of stand out. I have 2 2's. I have 1 3. And I have 1 5. So if you're sitting beside somebody and they start their factor with 2 times 30, they start their tree with 2 times 30, and you start your tree with 6 times 10, you're both right. We're both going to get to the final answer of 2 squared times 3 times 5. All right, so let's take a look at the number 45. Divisibility rules. Is it even? Nope. Is it divisible by 3? Let's see, 4 plus 5 is 9. 9 is a multiple of 3, so yes, it is divisible by 3. Divisible by 4? Nope, odd numbers are not divisible by 4. Divisible by 5? Yes, it ends with a 5. By 6? Nope, it was not divisible by 2 and 3. By 9? Yes. The sum of the digits is 9. So I'm going to start with the one I don't know it's easiest on this one, and that's 5 times 9 is 45. From your 100s chart that we did on Monday, we know that 5 is a prime number, but 9 is a composite number. 9 we get from multiplying 3 times 3. 3 is a prime number, so I'm going to have to stop. So now I'm going to highlight all of my prime factors. You always start your answer with the lowest prime number, which is 3. Since there are 2 3's, that would be written as 3 squared, and then we have 1 5. So final answer, 3 squared times 5. Now, if you want to check that, 3 times 3 is 9, so 3 squared is 9, and 9 times 5 is 45. Check. Let's try 88. Now, what in the world are we going to start our branches with? Let's see. 88 is an even number, so I could start with 2. 8 plus 8 is 16. 16 is not a multiple of 3. What about 4? I know that 4 is a factor of 8, so 4 would surely be a factor of 88. What about 6? Nope, it was not divisible by 2 and 3, not 5, because it does not end with a 0 or a 5. Not 6, it was not divisible by 2 and 3. Did I just say that? Not 9, not 10. Okay, so 2 is probably going to be the easiest one. Now, if you don't know what the other factor is over here, you can do something real simple. You can come over here and divide 88 by 2 to find that other missing number. So 2 goes into 8 4 times, and 4 times 2 is 8. Subtract, drop down your 8, and 2 times 4 is 8. So 2 times 44 is 88. So we're going to circle the prime number. 44 is not prime. The easiest one I know here, I know 4 times 11 is 44. I know from my 100s chart that 11 is prime, but 4 is composite. 4 is going to get branched off to 2 times 2. Okay, so I see a 2, a 2, a 2, and an 11. So we're going to start writing our answer with the lowest factor, which is 2. There are 3 2's in the tree, so that's going to be 2 cubed times 11. Now, if we're going to check our answer, I know 2 cubed means 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. And 8 times 11 is 88. Check. 70. All right, since this ends with a 0, I know the easiest thing to start with would probably be 10. I know any number ending with a 0 has 10 as a factor. So 10 times 7 is 70. If I look at my 100s chart, I know that 7 is prime, but 10 is composite. And I know 2 times 5 is 10. So 2 is prime and 5 is prime. So I've got 2 times 5 times 7. You write your answer in order going from least factor to greatest factor. So that would be written as 2 times 5 times 7. If you want to check yourself, multiply those numbers and make sure you get 70. So 2 times 5 is 10, and 10 times 7 is 70. Check. All right, we're going to make 2 separate trees for 48 because 48 has a lot of factors. This is when you want to keep going back to those divisibility rules. So is 2 a factor? Yes, 48 is an even number. Is 3 a factor? Let's add our digits together. 4 plus 8 is 12. Whoops, sorry. 4 plus 8 is 12. Yes, 12 is a multiple of 3. Is 4 a factor? Yeah, because 4 is a factor of 4 and 4 is a factor of 8. So surely 4 can go into 48. 5, no, it does not end with a 0 or a 5. Is 6 a factor? Yes, 2 and 3 were factors, so 6 has to be a factor. 9, nope. The sum of the digits 12 is not a multiple of 9. And 10, no, it does not end with a 0. So I could start with 2, 3, 4, or 6. So the multiplication facts that I know best for 48 are 6 times 8 is 48. On my 100s chart, 6 and 8 got crossed out for being composite, so those are going to have to both have a set of branches. So over here, I know 2 times 3 is 6, and I know 2 times 4 is 8. I know from my 100s chart that 4 is composite, so it's going to have to get branches of 2 times 2. All right, that's a lot of factors. So let's highlight those factors so we can see them more clearly. So how many 2's do we have? I've got 1, 2, 3, 4 2's, and 1 3. So what does that mean? That means 2 times 2 times 2 times 2 times 3. Well, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. What's 16 times 3? Oh, 48. Check. All right, so let's start with a different set of factors. A lot of you might want to start with a 2 because it's an even number. If you're not sure what the other factor is over here, you can divide 48 by 2. So 2 times 24 is 48. So 2 is prime, but 24 is not, so that's going to need some branches. I know that 4 times 6 is 24. On my 100s chart, 4 and 6 are not highlighted, so those are going to have to get a set of branches each. 4 is 2 times 2, and 6 is 2 times 3. So I'm going to highlight all of my prime factors. Oops. And then I'm going to start with my 2's. So I see 4 2's and 1 3. Now, if we compare my first answer, starting with 6 times 8, to my second answer, starting with 2 times 24, notice that we both got to the same answer. So even though you and a friend are starting your trees with 2 different factors at the top, as long as you did your math correctly, you should get to the same answer at the bottom of your factor tree. All right, let's try 102. Is 2 a factor of 102? Yes. 2 is an even number. 1 plus 0 plus 2 is 3. If the sum of the digits is 3, and 3 is a multiple of 3, then 3 is a factor. What about 4? I know 4 times 25 is 100, and 2 is only more than 100, so 4 couldn't be a factor. 5, nope, it does not end with a 0 or a 5. What about 6? So the rule is if 2 and 3 are factors of the number, 6 has to be a factor of that number. What about 7? Nope, don't think so. 8? I don't know. Let's see. So, oh my goodness. 0, 1, 8. Nope, that's not going to work. 9, no. 3 is not a multiple of 9. Okay, so let's go ahead and, sorry, don't know why my stylus is being weird. Now, if you don't know what the other missing factor is over here, we can, again, do a real quick division problem. We can divide 102 by 2. So 2 can't go into 1. We know 2 times 5 is 10. And 2 goes into 2 once. Oh my goodness. There we go. So 2 times 51 is 102. Now 51. Some of you might be thinking that's a prime number, but if you look at your 100s chart, it got crossed out for being composite. Now, why is it composite? If you add the digits 5 plus 1, you get 6. Oh, 6 is a multiple of 3, so 3 is a factor of 51. 3 times what? Let's find out. Oh, 3 times 17 is 51. So 3 is prime, 17 is prime. So the prime factorization of 102 is 2 times 3 times 17. Okay, this is our last one. Now 243, that kind of looks like a weird number, doesn't it? So is 2 a factor? No, this is not an even number. Is 3 a factor? Let's add our digits. So 2 plus 4 is 6, and 6 plus 3 is 9. Oh, yep. So 3 would be a factor. What about 4? No, odd numbers are not divisible by 4. 5, no, it does not end with a 0 or a 5. 6, nope, it was not divisible by 2 and 3. 9, yes, the sum of the digits is 9. Okay, so I have no idea what, so I'm going to start with a 9. I have no idea what my other factor is over here. So I'm going to divide. Remember, division is the opposite of multiplication. So I'm going to divide 243 by 9. So now 9 times 2 is 18. Borrow. 14 minus 8 is 6. Drop your 3. And I know 9 times 7 is 63. Okay, so this number right here, 9 times 27 is 243. Now, going back to the 100s chart, 9 is composite, so it needs 2 branches, and 27 is composite, so it needs 2 branches. So we all know that 3 times 3 is 9, and we know 3 is prime. And 3 times 9 is 27. And then 9 needs 2 more branches for 3 times. My goodness, look at all those 3s. Okay, so now we're going to highlight. I've got 1 3, 2 3s, 4 3s, 5 3s, and 6 3s. So this answer is going to look a little bit different. All the other ones we did like 2 times 3 times 5 squared, or 2 to the 3rd power times 5. This one is only going to have 1 base and 1 exponent. So this is simply going to be written as 3 to the 5th power. All right, that is it for prime factorization. Email me if you